Hello and welcome back. All right, so let's get started with some basic stuffs. We will start with the very first question. What is IoT? What is Internet of Things? We will try to understand this with one or two examples. So let's take example of a smart building in which we have a smart fire management system. In a smart fire management system, you have sensors and the sensors are deployed across the building premises. And then the sensors keep detecting the temperature in the environment and they keep sending this temperature to a command center using some kind of network. And this command center keeps monitoring the temperature, and whenever the temperature is beyond a certain level, it will issue a command to a sprinkler which will start spraying the water. So this is how a smart fire management system works. Let's look into these components one by one. First component is sensor. The sensor is a smart object. It does not only senses the temperature, it also sends the temperature to a command center using some kind of network. So it has the ability to communicate. And this command center keeps receiving the information from the sensors. And then there are hundreds of sensors deployed across the building premises. Right? It's not just one or two sensors. There could be hundreds of sensors because the building could be quite large and complex. And command center keep monitoring the information which is coming from the sensors, and whenever the need is there, whenever command center thinks that it's crossing a certain boundary, then it will issue a command to a sprinkler, and this sprinkler is also across the building, so the command will be issued only to a particular sprinkler from where some abnormality is observed. Now if you see in this process, the first process is data collection. Data is being collected using temperature sensor. Temperature sensor is sensing the temperature and it is sending the information to command center. The second part is data communication, which is happening through some kind of network. It could be wired or wireless network. The third part is data processing, which is happening in the command center, which has all the computing infrastructure, all the information which is getting collected from the different sensors. They come to command center. Command center will do all kind of data management stuff, and then eventually there is a actuation where the actual action happens based upon the command from the command center. Let's take one more example of asset tracking across supply chain. So in asset tracking across supply chain, there are some goods which are getting produced in a factory, and then these goods are shipped to the retail shops, and during the shipment it may be going through trucks, some kind of ship or aeroplane, and then eventually it lands to the store. So there could be multiple agencies, and with each agency there could be multiple departments, and therefore we need to track the goods throughout the life cycle, both indoor and outdoor. So when it is in factory, which department it is with, and when it is in shipment, where exactly it is. You may want to know the exact geolocation also. And in many cases, remote monitoring and control of assets may be required, specifically if it is an expensive item. For example, if you have jewelry which is getting produced in some factory and getting shipped to the retail store, jewelry is an expensive item. So there could be more stringent monitoring and control system which needs to be implemented. Similarly, if you have a perishable items, for example, you have some medicines or you may have some fruits, vegetables or meat, in those cases, temperature inside the truck may be required to be monitored. And chain of custody is needed. Chain of custody means throughout the life cycle, the good has gone from one agency to other agency, and then from one department to other department. So throughout the life cycle, who all has handled the good, for how long it has been there with that particular department or particular person, the entire history of the movement of good needs to be tracked. Whenever there is any kind of mishappening which happens, in that case, the history will help to do the investigation. And then in many cases, product status and health also needs to be continuously monitored. For example, in case of perishable items, fruits and vegetables, constantly we have to keep monitoring if the item is in right state or not. In this kind of system, the trucks in which the shipment is happening, they could be equipped with some kind of GPS tracking mechanism, either using satellite or using cell towers, GPRS system. And all this information through satellite or through cell tower, they get stored in some kind of central server. So throughout the life cycle, all the data which is getting collected and how that data is getting collected, that is again using different kind of equipments, different kind of devices or sensors, and all this information from different places they gets collected to a central server, and then from that server the information can be fetched for monitoring, tracking, controlling, and whatever activities we want to do. So one important thing which can be done is real-time tracking, either indoor or outdoor. When the product is within a warehouse or within a factory and it is moving from one shelf to other shelf or one department to other department, the tracking can be done. And when it is being shipped in the trucks or in ships, then also the real-time tracking can be done where exactly my product is. Inventory management and control uh, will feed all this data from whatever data is getting collected from different sources. All this information will go into inventory management and control system, and using that data we can do all different kind of analytics. We can do monitoring, we can do the tracking, we can also do remote control in certain cases. Alerts and notifications can be sent. For example, if you have a jewelry which is getting shipped, you do not want to, there could be lockers in the trucks, and you do not want to open the locker by some local person. It can only be opened by somebody sitting in the command center, only by the authorized person. Right? So that remote locking of the door or remote opening of the door may be required in case the door is getting opened without intervention of the authority, then the notification alert should be thrown. So this kind of abnormalities or alerting mechanism can be put in place. And then of course chain of custody. During the entire life cycle, the good has gone to which person, which department, all those tracking can be done. So in this again, if you see, the first part is data collection, and data is collected using different kind of sensors. There could be GPS sensors, there could be RFID enabled tags which will be attached to the product. There could be BLE beacon. So BLE stands for Bluetooth Low Energy, and there could be temperature sensor. So depending upon what use case, what kind of inventory is there which is getting shipped, you may have to put those kind of uh, data collection sensors or devices. Then the communication has to be there. Right? In communication, you can have LAN, WAN, or personal area network. For example, let's say there is a truck. Right? In this truck, jewelry is getting shipped. So there is a locker in the truck, and then you have a camera here which is monitoring the locker. There is a real-time feed which is going, and then you may have some other kind of door sensor here. Whenever the door uh, is locked or gets opened, this sensor will play the role. And then you have a, a kind of Wi-Fi system here, right? So this devices, the sensor over here in the locker, the camera over here, all these devices will connect to the local Wi-Fi router or the gateway. They may not have capability to connect to backend system, to the cloud system. Right? The sensors may not have that kind of ability. So they may be Bluetooth enabled devices which could connect to the local Wi-Fi router, and then Wi-Fi router will connect to the cloud. All right. So in that case, you may need Wi-Fi, you may need LAN, and you may need WAN also. So it all depends. So in the next section, when we talk about networking, when we talk about different layers of processing, then we will talk in more detail how there could be different kind of communication equipments required in different stages. Then of course you have the backend system where all the data will be landing, data collected from all different sources, and then data gets processed, and then we do the real-time monitoring, processing, real-time control, whatever we want to do. And in some cases actuation may be required, like door locking or a buzzer kind of thing. If there's any abnormality, the buzzer will start blowing. So from these two use cases, what we have seen, let's define what is IoT. IoT has two words, internet and things. It's internet of things. So there are two words. Internet basically means interconnected, and thing means smart object. What is a smart object? What are the attributes of smart object? We will just talk about it. But in general, the definition of IoT based system is IoT based system is something which can sense, which can compute, which can communicate, and which can perform some kind of action based upon the computation. So what is smart object? We have seen that Internet of Things has two components. One is the networking, which is interconnected, and second is the smart objects. So IoT is all about smart interconnected devices. Smart interconnected devices. Smart devices means we will just understand what is a smart device. And then interconnected means they can talk to each other. There's a communication system established between them and they can talk to each other. So in IoT terms, a smart object is something which can sense, which can communicate, which can process, which can take some kind of action, and which may have some kind of application software for management and control or monitoring, configuration, etc., etc. So if you take a simple example at home, all of us may be surrounded with many different kind of smart gadgets nowadays. So one simple example is smart speaker. Let's take example of smart speaker. A smart speaker has a microphone, which is the sensor. Then it may have speaker. Speaker is the actuator. Or in case it is connecting to other smart object, for example, smart speaker like Alexa at your home, it can connect to the smart light, smart fan, right? And it can take commands. If you say Alexa, switch on the light in bedroom number 1, so it will take the command and switch on the light. So smart actuator is your speaker plus other smart devices which is connected to the speaker. And then it has Wi-Fi connectivity to connect to the backend cloud system. And then it has many computation thing which happens, speech recognition, natural language processing, generative AI. There are many different kind of AI software components which are being used in the back end to do all different kind of processing. And we also have some applications for configuration. You have a browser based app, or you have Android or iOS based app using which you can do the configuration. So this is a simple example of a smart speaker. In our next session, we will talk about how this smart object works. We will take example of smart speaker Alexa. From outside, from a user perspective, this seems to be quite simple, but behind the scene, there are many complex technologies which are integrated to make it happen. So we will just take this use case of smart speaker and we will do an anatomy of smart speaker, and we will see how behind the scene different technologies are integrated to make simple things happen. So with this understanding, this is the simple and basic architecture of IoT system. So you have sensors, then you have actuators, and then we have devices. Sensor, actuators, and devices are mostly clubbed into one logical unit, which is called thing. Thing means a smart thing, a smart object. Any smart object in IoT terminology is called thing. Now onwards, whenever we say thing, thing means it's a smart object. Smart object means it will have ability to sense, it will have ability to do processing, it will have ability to communicate, it may have some kind of actuators attached which can take some actions. All right. And then you have a backend system where all the data management, all the servers, your computing infrastructure will be there, and majority of the processing will happen in the backend system. And then in between, we have network. There could be LAN, there could be WAN, there could be personal area network like Bluetooth or Zigbee. And then you have different kind of applications which are used for different purpose. Applications may be used for monitoring, applications may be used for various administrative work, applications may be for user for configuration and management from user perspective. There can be different kind of applications. So at high level, this is a very basic 4-tier architecture of a Internet of Things ecosystem.